Hi everyone, I'm Jay and today we are going to see the example for the subnetting. So the question is, a network is given that is 200.1.2.0. We want to do the subnet of this network. So we have to divide this network into two parts. Okay, so we have to find the first and last address of each subnet. So let's write down the network that we have given, that is 200.1.2.0. Now this network is having two information. The first information is the network ID and the remaining is the host ID. Now which portion is network ID and which portion is host ID? So to find the network portion and the host portion, you should know the class of the IP address. This IP address is of class C. So we know that for the class C, first 24 bit is for network ID and the remaining 8 bit is for host ID. Now what is the meaning of network ID and the host ID? Network ID means for one network, the value of the network ID will remain constant. And the host ID, it means the value of the host will change in one network. So we have given this one class C network and we have to subnet this network. Now to do the subnetting, we cannot make change anything to the network ID. We have to do something in the host ID. Okay, because the network ID is fixed, we cannot do anything to that. We have to do some changes in the host ID. So how we can do changes to the host ID and how subnetting is done? So let's see. To do so, first of all, let us convert the value of host ID in the binary. Because the value is 0, when we convert into binary, it will be 8 bits. Now, you have to see that how many subnets we have to create. Right now, we have to create how many subnets? 2 subnets. So, to create the 2 subnet, we will convert 1 bit from the host to network. So, in the host ID, there are 8 bits. From those 8 bits, the 1 bit will be converted into network. Now the question is, why 1 bit is converted? Because we want 2 subnet. So 2 raised to n will give you the number of subnet, and what is n? It is a converted bits. So if we convert 1 bit, we will get 2 raised to 1, it means 2 subnet. If we convert 2 bits, we will get 2 raised to 2, it means 4 subnet. Right now we need only 2 subnets, so we will convert only 1 bit. So let's convert the bit into network and the remaining bits are for host. Now the meaning of these bits is very important. The value of the converted bit, which is the first bit, okay, this bit, the value of the converted bits should remain constant for one subnet, and the value of the host bit will keep changing in one subnet. So if I want to find the range of the first subnet, the value of the converted bits should remain same for that subnet. And if I change the subnet, the value of the converted bit will change. So based on the converted bits value, we can define that which subnet is which. First of all, I want to find the starting and the ending address of the first subnet, that is subnet 0. So to find the starting and the ending address, we will keep all the host bit 0 because we want to find for the subnet 0. So the value of the converted bits will remain constant and the host bit will be all 0 for the first address, and for the last address all bits will be 1. You can notice that the value of the converted bits are not changed. So these are 0 and 0. Now if we convert this binary into decimal, we will get the first address, that is 200.1.2.0, and the last address is 200.1.2.127. Okay, now we want to find the range for the second subnet. So let's do the same procedure. We know that we have to convert into binary, and now you can see that the value of the converted bit is changed from 0 to 1. So for the 0 subnet, the value of the converted bits was 0. For the first subnet, it will be 1. So this value should be remain constant throughout the subnet, and the host value will change in the subnet. So for the starting address, all the host bits will be 0, okay, and for the ending address, all the host bit will be 1. Let's convert into decimal. So we will get the first IP address 200.1.2 201.128 and 201.2.255. Now we can find the total number of IP address per subnet as well as the number of subnet. We have just discussed that to find the number of subnet, we have to use the equation 2 raised to converted bits. So if converted bits are 3, we will get 2 raised to 3, 8 subnets. Right now, we have converted only 1 bit because the needed subnet was 2. You can also find the number of IP addresses per subnet. So the remaining host bits were 7 in this case. So 2 raised to 7 will be 128 IP addresses in one subnet. And this is how the subnetting example is solved. Thank you.